Okay. Yeah, thank you. You may ask any question during this meeting. You can ask any question if you have any doubts and you want me to repeat certain thing. You can stop me by typing on this chat box here. Okay. Anyway, somebody joined in here already. The second student. Okay, welcome. SIM. Who is the SIM from Ipoh?
Sir, it's me, sir. Suraman.
You can hear me, right?
Yeah.
Okay, thank you. All right, we're going to start right now. Okay, this class is the electrical circuits and power. And from my experience, most of you are the very new to WOU, and I need to tell you some of the fundamental things that you should know. How to complete this course successfully. Am I right? Most of you are new to WOU.
Who, sir?
How about you? Are you new to WOU?
No, sir. No.
You mean you already old student?
Yeah, I'm about 5 years already.
Already?
Yep. I'm in the 5th year.
But I think this is the new student, the first year class, right? This is the first year subject, right? I think.
I mean for this year, this is the first subject for me, lah.
Oh, really?
Yes.
Oh, I thought this is the first semester subject actually.
No, sir.
Oh, okay. All right, never mind. We just go ahead and start right now. Can you please type your name here? You type your name on this meeting chat box here, and later I need to go through it and mark your attendance. Okay, make sure you type your name here, all right? Okay, what you should do actually, you need to go to this website. The first thing, this semester we have a new website. We need to log in to access to all the course materials. Okay, it's called the FlexLearn WOU EDU My. Okay, you look at the address bar here. You just sign up using your student ID, student emails. You sign up. All right, let me show you. In this course, there will be 2 assignments plus a final assignments to replace your final exam. And that means almost everything you have to do it online. There's no final exam to take actually. You don't need to go anywhere to take the final exam. What you need to do is to complete your final assignment. Okay, now we go right into when you are in. Okay, when you're in here, you need to find the assessment. We call the assessment. We go to content. I think your assessment, the assignment will be 10%, 20%, 20%. Okay, let me write down here. I'm now talking about your assessment. First, you need to complete so-called the assignment 1. And then followed by assignment 2. Okay, and then there will be one final assignment. final assignment. And also there'll be one online quiz. I think there'll be one online quiz there. I saw it there. I saw it, there's one online quiz here. If there is a quizzes, that means they will occupy about 10%. But currently there's nothing here. For some subject we have a quiz you need to take actually. Probably for this subject you don't need to do the quizzes. But I'm quite sure you have 3 assignments you need to complete it. Okay, it's all under the course assignment here. And you can go right ahead and download the assignment number 1. I think the due date is near also. And also you need to remember to sign the declaration form. That is to declare that you know the plagiarism policy, and you're aware of the policy. Okay, this is assignment 1. So it carries 25% of the total grade. So assignment 1 25%. I presume assignment 2 also 25%. So altogether 50% for the assignment 1 and 2. And final assignment should be 50% in this case, because in the past there was no quiz for this subject. So I think the quizzes here is applied for other subject. Okay, not for the engineering subject. It's not suitable actually. Okay, so I'm here to help you understand some of the basic in each topic, and also help you to complete your assignment. But I cannot provide you the answer because I'm the one marking your assignment, as you know. Okay, so this is your assignment number 1. And today we will go through probably question 1 only. If we have time, we'll probably go through question 1 only. Okay. Let me see. Okay, let me check your assignment's due date. Let me let you know about your assignment due date. This is very important. You need to take notes of this due date here. Okay, so currently, of course, there's nobody submit the assignment right now. So the due date here I can see is on the 30th. On the 30th of January, so it's quite near actually. It's about 13 days away. Okay, your assignment 1. Due date usually fall on Friday. The due date will be on the 30th January. So it's quite near actually. And then you have to remember that next week we have the a lab session of a 4 hours lab session coming up next week. So it's quite tight. The schedule is quite tight actually. Okay, so I'm sure the date is correct. All right, let's go right into the topics right now. Okay, this course is about some of the fundamental things in the electrical engineering. So we learned something about how to analyze electrical circuits, mainly DC circuits, but we do have one topic involve AC circuits. Okay, and some of the topics also cover how to calculate the power of the power consumption or the power absorbed by a circuit. Okay, we need to learn about all the some calculations and the way how to analyze the electrical machine, something like transformer, motors, electric motors, generators, how to calculate their powers, and how to calculate the circuit's powers. And you can say that more than 50% are involving the circuit analysis. So which is the you can find in topics 1 and 2 on topics tutorial 1, 2, and 3. So totally we have 5 tutorials, and we have 4 online sessions to cover these 5 tutorials. That means today we need to cover tutorial 1 and some of tutorial 2. That's why today we have 2.5 hours. All right. For today's topic, we're going to talk about some basic, some physics. Usually, most of them are physics. Actually, you can find in physics, electrical quantities, Ohm's law. Ohm's law is the very basic thing you should learn when it comes to circuit analysis, followed by the Kirchhoff. We have voltage law and current law, and then we learn how to calculate the total resistance in series and in parallel. So I hope all these terms are not no. I hope you clear about all these terms, and you're familiar of all these engineering terms here: resistance, voltage, current. So if you don't know, you can ask me. I can explain to you. All right. The first thing here is about the quantity, the units. Actually, the units. Okay. We are not going to much about all these intensity, all these various units in engineering. I think most of you understand what is a meter, what is a kilometer, and second, all the unit and the symbols. When it comes to engineering electrical circuit, usually we use volts, ohms for resistance, and farads. Okay, and some of these like Newton, all these are used in the physics. We are not use them very much in this course. Even though the Joule define the energy, we are not you are not see them very often. Okay, so what you can say that is most of the unit that start with the electric here, I think you're going to see them very often here. Okay, and beside that, I think you should know about some of these prefixes here. Usually what we use the mega, 10 to the power of 6, and micro, because some of the components value we're going to dealing with in this course, like the capacitor. If you heard of capacitor, usually the capacitor are value using this unit, a micro farad. Okay, when it comes to inductor, we're going to use sometimes we use a micro Henry or nano Henry. Okay, that's why you need to be familiar with all these simple prefix here. I think you learn this in other subject also, so I don't talk too much about this. Okay, let's look at the some of the physics things about this current thing. Okay, the current we are talking about here is actually a flow of charges through a point. It's called current. All right, and you can see the total charge, the one electron carry a charge of 1.602 multiplied by 10 to the negative 19. So what you do here is, if you take this number 1.602, okay, you take this number 1.602, and then you use the prefix here 19. Okay, you put a minus sign here, and then you do the 1 over x here. You convert to 1 over x. Actually, this number here, okay, 6.24 to the 10 of the 18. I don't know how to convert this one. 6.24. Okay, I roughly remember the number 6.24 to the power of 18. Okay, if you reverse this one, you reverse it, you get 1.62602 to the power negative 19 here, this number here. So what this number here actually is the total charges passing through a point in 1 second. So that's what we define as a 1 ampere. So let me draw you something. Let's say you have a wire. Okay, let's say you specify this is the point A, and there are many electrons carry the charges in a wire. When electron passing through this point, okay, when there is 6.24 times 10 to the 18, which is really large, so there are enormous amount of the electron passing through this point in 1 second per second. So many electron carry charges passing through this point A in 1 second is equal to 1 ampere. That's how we define the ampere here. Okay, but all these are physics. You don't need to actually be very good at physics in this course. Just to let you know at least the basic things here. Okay, it's a 1 coulomb per second, defined as 1 ampere. 1 coulomb per second, 1 ampere. Right. I think you can search for, you can easily use the Google to look for this coulomb, to define the coulomb here. So it tells you the some of the basic here, right? 1 coulomb ampere per second. But all these are physics actually. You don't need to know in detail. All right. So let's go to something very important here. And the current, when you try to express using the formula, mathematical formula, is the total of charge, the change of total the charge over the change of time. Okay, you can define something like this. In other form, the current is equal to change of the total charge over change of the total time here. Okay, that means within this time we have so many charges changing. This called the we call it current. How many currents? Okay. So if you take the Q here, you move this over, you move the dt over, then you actually reverse to integration. So the charge, the total charge is equal to integration of between here this time and the t0 to t1, and then the I dt, the I dt. Okay, these all the mathematics I think we learned in the secondary school. We can actually reverse all these things. The integration and the differentiation. Okay, so this is a simple example here. You look at this example. So the total charge here is defined by this equation, Q equal to 5t sine 4 pi t milli column here, column. Okay, so you need to evaluate this equation for the time equal to 0.5. So if you put this 0.5 into this equation here and here, there are two t here, the t variable. You put in 0.5, 0.5 here, and then you can evaluate the total charge. Okay, but you know that the currents. Oh, okay. You are not only need to evaluate the charge, you need to evaluate the current. So the current is not equal to charge, right? The current is not equal to Q. The current is equal to dq dt. That's why you need to differentiate this equation here. After you've done the differentiation, you end up with this term here. Okay. After the differentiation of sine, you get this function here. Okay. Then after that, you just put in the t. You insert t equal to 0.5. Then at the end, you're arriving at this value here, 31.42 milliampere. Okay. So this is most of the questions are actually in this form. You need to be prepared. Okay. For example, you can actually doing the reverse. Actually, you can do the reverse. So example, in the exam, sometimes the thing will reverse. Okay, example, they'll say I equal to 24, for example, sine 2 pi t. Okay, so ask you to find the charge, the total charge. It's the reverse, right? From here to here. So you know that from the first equation, here, I equal to d q dt, and then q equal to integration of I dt. So what you need to do is to integrate this function dt, okay, from the t0 value to t1 defined by the question. Actually, if this is provided the current, you can do the reverse, calculate the total charge here, okay, using the integration. So there's a meaning of these two equation. You can convert from here to here and here to here, depending on what function you have. Okay, you can actually do the reverse. All right, this is about the proton, because in one charge, in one proton here, we have this small amount of charges inside the proton. Okay, defined in coulomb. So you can see this number is really small. 10 to the power of -19 is very small. That is the total charge in one proton. Okay, in one proton, there's a total charge inside the proton. Okay, and also inside the electron also, they are equal amount of charge inside the proton and electron. So if you have 2,500, that means you just need to multiply this number by 2,500. So this one is quite straightforward actually. Okay, when you come to the basic here, every proton or electron, this is electron, right? Sometimes you can use a proton. They are same amount of proton and electron. Every of these electron, they carry the total charge of 6.0204, right? Or 1.602. They carry, each of them carry 1.602 times 10 to the minus 19 coulomb. Okay, if they are 2,500 passing through this point, then you just multiply 2,500. Okay, these are the two just a physics, most of the physics stuff. Okay, so we don't want to spend too much time here. So you have now you look at this voltage here, and we can also associate the voltage with the work energy, the work. Okay, the voltage actually defined as a change of the work over the change of the charge. So this is a bit not so famous, this equation. You're not going to see this equation very much in this course. Okay, and the voltage actually is it's actually a potential between 2 points. That's what we call the voltage. It's a potential. We need to have some kind of potential difference. So what I mean is, let me save this one first. Okay. Hold on there. Later I can share with you all the slide here. Okay, when it comes to voltage, we need to have some kind of potential. For example, let's imagine in the physics, okay, you are standing here, okay, so this length is higher than the length here, so there are potential here, right? This is called the potential. That means if you jump down here, you may get hurt, right? Sometimes you may hurt your muscle or something, your joint, if you jump down from here to here, because there are potential here. We call the potential. The height are different. When it comes to voltage, it's also the same thing. So if you are standing on a total flat ground here, there's no potential. You're standing here, point A and point B. The potential is 0. Okay. But when you talk about the voltage, sometimes we talk about the potential like this. This point and this point, in between, they are potential, right? They are potential different here. We call the potential different. Change of voltage here. Here is a V1. Here's a V2. So we can see there are some potential different here. Also here and here, they are different potential, right? But this one has no potential here. Okay. And most of the time in the circuit here, the potential can be found between 2 points here. Let's say you have one resistance. This is a symbol for the resistance. So the voltage we call the node voltage here. Usually we call this one the node voltage. The node voltage here and the node voltage here, actually there will be a difference because this is a resistance. Okay, you can find two voltages here across one resistance here, a resistor. But when you talk about a wire, just a straight short wire, if you talk about the potential here, actually they are the similar. V1 and V2, actually they belong to the same thing. Actually, there are no potential with in the short wire. Okay, unlike this one V1 is not equal to V2. Okay, usually the V1 let's say here is a power supply. Let's say you put a battery power here, and here's a positive polarity. The V1 will be larger than V2 in this case, okay? Because this one is near the power supply. This one, after the resistance, the potential will drop, just like this one, the potential will drop. Right? This one also, the positive higher potential here, this lower potential here, right? So when you analyze a circuit, when there's a straight wire, you cannot say there are two voltage difference between a short wire. Okay, this is not true. Even though the sometimes the circuit may appear that they have some kind of potential. Example, let's say you have one circuit like this, resistance, and then here's a the way how they draw this circuit, something like this, and then they draw this all the way 90 degree turn here, and then they say here's a ground. Okay, they say here's a ground. To some students, probably they think that this is a potential, here's a potential, right? But so because here's usually is 0 volt, the ground usually is 0 volt, has no potential at all. So if you do this V1 and V2, that means it's wrong already, right? Even though they may appear there's some potential here, but when it comes to circuit analysis, this V1 and V2, they actually similar to here, V1 and V2. Actually, they are actually there's no potential here, right? There's just one straight wire. Unless you see one component here, then you can assume that before and after the component, there will be a different in the potential voltage. Okay, that's why this try to tell you here, VAB. Okay, and if you differentiate the voltage here by time, differentiate the dt here, dw dt, you can get the power. Okay, the power actually is the change of the work over the change of the time. So the work here actually is the energy. The change of energy over the change of time is the power. Okay, we define the power and energy. And power and energy, they are really close actually. Okay, power usually is the power output, and the energy is something like energy can be absorbed by some component, or the energy generated by some component. But usually the most of the time is energy absorbed by the resistance. Sometimes we say the resistance is the load. Sometimes we are more dealing with the load, okay, which is drawing the power from the power supply. We call the load here. Okay, it's actually consuming the energy or absorb the energy here. Okay, when you do the when you play with all these equation here, dw dt, dq dt, okay, because the power, to calculate the power in a DC circuit is just, you can just multiply the V times I. Okay, but we can when you play with the Ohm's law later on, you can find that the power also can be defined as I squared times R. Later on, you can find this one like this, and also you can calculate this one as a V squared over R. Okay, and when you play with all these equation here, the V actually, just now we know that is the dq d work dt, right? And the I, just now we know that is the dq dt, the change of the total change of the charge over the change of time. So if you play with this one, you take away the dq. Okay, dw dt actually is the power. Okay, and you break away this dw dt, dq dt, you get the v times I actually. Okay, let's start with this one. Power equal to dw dt. Okay, so you put the dw here, you put something below empty here, then you put the dt here. Okay, then what you do, you have to put something here which you can cancel it. Okay, then we put the dq here, we put the dq here, you can cancel, right? Then this one is actually the v, this one actually is the I. This one to show you that sometimes we can play with all these function here, or the equation, by just substitute all these dq here, or substitute dt, we can actually change some equation and try to change the equation from one form to another form. Okay, by doing all this moving of this variable. Okay, and this is the physics, actually the law of conversion of energy. That means the sum of energy in the circuit must be 0. So this equation tells you in one circuit there's one source, and most of the components are the load actually to consume the power. I think this one will appear in your assignment number 1. Yeah, here, part C. In this question, we are dealing with the thing that can supply the power. They call the element here. There are 3 elements here. One, usually there's some element supplying power. Some element actually they are dissipating the power. So this dissipating power, that means they are absorbing the power actually. In other words, is they are consuming the power. One supply, probably 2 consume. So what we are talking about here is, let's say you have one power here. You have one element to generate the power. Let's say here's a power supply. Okay, let's say this is a power supply here. Let's say you have a certain volt here, and then this power supply actually allow the current, generate the current also, right? The power supply can provide the voltage and provide the current. And let's say you have one element here, which is usually the load. We call it the load. Or if you are not sure, you just call it element. So for the 3 element here, you see this is the first element, and now we know that this is a voltage, this is the load here, and when the current passing through this resistance here, actually the power absorbed by this resistance is equal to the voltage across these two, the potential difference voltage across these two multiplied by the current. Okay, so let's say you end up with example 2 watts here. Example, okay. So let's say you got another voltage potential here, because there's a resistor in between here. So the voltage here and the voltage here, there's a difference. So we call the V2. Okay, and then the same current also flowing through this circuit here. Okay, so here the power absorbed by this component here is also the same formula, V times I. Okay, let's say it's equal to 3 watts. Okay, that means this power supply actually need to supply 2 watt plus 3 watt. So what you can say that is a power input is actually equal to 5 watts. Okay, and the power output is equal to 2 watt plus 3 watt. So you can also rewrite as 5 watt is equal to 2 watt plus 3 watt. So if you sum of all this, okay, you throw this one over, it becomes 0 equal to 2 watt plus 3 watt minus 5 watt. The sum must be the 0. Okay, because you cannot have one circuit can generate more than 100%. Okay, the sum of all the circuit, all the power must be equal to 0. That means that there will be a 1. There will be the one that is the generating the power. That there will be the one that is supplying the power. Okay, but there will be some component that is the absorbing the power. Okay, the supply and the absorb all together. If you sum all this together, because the minus sign here, you sum everything together must equal to 0. So you come to this case here. This is the unknown component here. So we call it element. We call it A, B, C. Sometimes by analyzing the polarity, you see this one start from positive to negative. This one start positive to negative, right? And this one negative to positive here. Sometimes by analyzing the polarity here, we can tell whether which one is supplying or which one is dissipating. You look at this example here. The polarity here is minus, the polarity here is plus, and plus here. So we can say that 2 plus 3 equal to 5. The 5 must be the one supplying the power, not these two. Because these two having the same polarity here, they are positive, and only one is negative. And this negative is a total of all the positive. That means this must be the supplying power. This one must be the absorbing the power or using the power. So you can try yourself. You can try yourself here this week, because we need to meet again on the 24th. Next week we're gonna meet again. So if you try this question, you still if you still couldn't figure out how to actually tackle this question, then you can ask me again. But I give you the hints right now is you need to analyze the polarity here. Okay, for example, let me give one example right now, which is very similar to this question 1C. Okay, I'll give you one example right now. When you go back, you try to analyze here. When you come to electric circuit, usually we have a battery power. Let's say here I put 5 watts. Okay, usually the long one is a positive polarity, the short one has the negative polarity. And usually when we try to symbol a load, we use a resistance. And here there's another resistance here. Right? This time we know the element is the resistance. Okay. So here we usually when analyze a circuit, we usually start from this positive. Okay, we start from the positive here. The current start from here. Okay, so this is the V1 because there are two potential different here. The V1 positive is here, right? And then we have the V2 because the current is flowing down. So the positive is here, negative is here. So in this case, it's very obvious, right? Let's say I say this one is a 2 volt. This one is 2 volt. 2 volt and 3 volt. And then it's very obvious that this one is supplying power. But because right now it's so obvious, this one is a battery. Of course, the battery is the one supplying power. But when you come to the case, this one is the unknown. This is the unknown. This is unknown. And what you know is they are joining together like this. 3 unknown. Okay, I want to give you one more hint is this element, the polarity here is positive, negative. Here's a negative, positive. Right, exactly the same. They are unknown here. That's what we call elements. And then for here, you can analyze. Let's say this is a 5 volt, right? If we start from here, negative 5 volt equal to, wait. Negative 5 volt. Here is a start from positive. Here we start from negative here. If we go this direction, when you first come in here, you see the negative. Okay, because we're going up, so it's negative 5 volt. When you go into this element, we see it's a positive, so we say it's a positive. Then we come down here, we also see positive. This one is a positive here. So you want to make sure if this all, if you sum together equal to 0, are they equal to 0? Of course, right? -5 plus 2 plus 3 equal to 0. That means this assumption is correct. Here is the positive, negative here. Okay, but without knowing which one is the battery, you look at the polarity here. You look at the sum is equal to 0. If it's equal to 0, that means this assumption is correct. If you apply the same concept here into this assignment here, you need to look at the polarity, okay, to determine which one is supplying power, which one is absorbing the power. We call the dissipation. Another word for absorbing the power is called the dissipation, power dissipation. Okay, so this one is is not so difficult right now, right? Okay, let's carry on.
Sir.
Yes.
Sir, for the answer for the question 1C.
Wait. You talk about question 1B. You talk about this question. Is it right? Am I right?
Yeah. The just now the polarity one.
Oh, you mean this one?
Yes, I mean yes, this one. Sir, is there mention the first one is identify which element in figure 3 are supplying power and which are dissipating power.
Yeah.
So in this term, we need to answer by the words or by the calculations.
You sometimes you need to use both. Sometimes both. To make your answer really clear, sometimes you would use whatever thing you have, like the words or the equation, to support your answer.
How about the second one also? The determine power dissipate is also same.
Okay, that means this one is so clear. Determine the power dissipation or supply, right? So you say A is supply, B is a supply, something like that. So the answer is straightforward. You just say A, B. Example, you say just example only, right? I haven't analyzed yet. You can say A and B is equal to supplying power. Something like this. Okay, but I want to make it clear that when it comes to the engineering answering question, sometimes we need to use whatever tools we have to support our answer. So what I mean is sometimes when we need to construct a table, to use a table to support our answer, we need to do that actually. Sometimes we need to draw a circuit to support our answer. Sometimes we need to derive an equation to support our answer also. So you have to use whatever the method you know, which can help to explain your answer. You need to use that actually. You know, sometimes we need to draw a figure. Sometimes we need to draw a graph. Okay, that means we use whatever means we have to explain our our points actually. Okay, so there's no limit to whether you just use word only or just use equation only. If you think it's a helpful to answer your question, then you need to use it actually.
Yep.
Okay.
Okay, sir.
But sometimes by using the words actually sometimes is not good enough to explain certain thing, as you know, right? Because sometimes people don't like to read the words. People like to see the figure, some figure. So if you can draw some figure, it will help to explain your answer sometime.
Okay, sir. Clear.
Okay, thank you.
Thank you, sir.
All right. Okay, let's proceed, because we cannot stop here forever. Let's proceed further. So when come to the another equation here, we can see actually from physics also, the total work done is the total of power you do from this time to this time. So much power you apply from here to here within this time period is defined as the work done. Okay, that means you need to sum all the power. You need to sum all the power within this time to this time. I can describe it in the using the waveform. For example, this is a timeline. For example, from T, let's say here's a T0, here's a T1. Between here and here, you applying 3 watt to do the work, and then from T1 to T2, you applying another 5 watt. Let's say here's a 5, here's a 3. So the total work here, because here's a power, right? So the total work done from T0 to T2 is equal to 3 watt plus 5 watt. Sometimes you can use this symbol here, total work, right? From T0 to T2 is equal to 5 watt. From this period to this, from this time to this time, right? This defined by from here to here, the sum of power. We integrate everyone slowly from here all the way to here. Totally we get 8 watts here. 3 plus 5 equal to 8. Totally we get 8 watts here. Okay, and then if you you convert this P also equal to V times I. You also can rewrite. You also can rewrite this equation, change the P to VI. Sometimes we can do that. Okay, and then the unit for the work is actually the joule. Energy okay, the word unit is joule. The power unit usually is a watt, and you need to convert between these two sometime, joule and a watt. Okay, but this is just a small topic. Okay, it is not very important right now. Okay, now here we got something we call the dependent, and I think we need to move a bit faster here. Okay, we have something we call the dependent source and independent source here right now. In dependent source, independent, and dependent. Okay, so when you play when you try to find all the possibility here, actually you can find about 4. You can find about 4 possibility. So let me try to express in another way. Let's say we have this the most common parameter is V and I and V, the current and the voltage. So if the voltage is depend on the current, in this one is depend on the current, that means we have current. They use the word current control voltage source, because this depend on this one, so it's a current control. When it depend on this one, that means this one control this one, right? You depend on me. This way I can control you, right? So this is a current control voltage source. Because if you play around with this one, you can also come up with voltage control current source. Actually, the current is a C actually. Okay, current is a C. Wait. Let's use back the general term they use. Voltage control voltage source. Okay, so we have four. One is the voltage control current source. These two are the different words actually. Voltage control current source. Current control voltage source. Voltage control voltage source. Current control current source. So we have four possibilities actually. If you find all the possibility here, with all these components, which one depend on the other. Sometime, example here. Let's say you have one resistor here, and here you got one current source here. Okay, let me draw it better. So this symbol actually tell you this one is a current source. Okay, by looking at the symbol here, I can safely say that this is the current source. That means this one supply the power actually. It supply the current. Because how do I know it's the current? Because I look at the arrow. There's an arrow here. Because usually in the circuit analysis, when we're using the arrow, usually it means the current. Okay. So if this one here, I say this is the VB. I name this one as VB, and this one I say is a 3 VB. So what does it mean here? What am I trying to tell you right now, or express? Why I say VB 3 VB? That means this one is a current source. This current source is controlled by the VB. This is just a constant controlled by VB. So VB is here. So you can say this thing here is a voltage control current source, because this is a voltage. This is a current source. And this one controlled by this one, because this one we can see 3 here. Again, we can see VB here. That means VB can control the total amount here. For example, let's say the VB is a 2 volt. That means this thing is equal to 3 times 2 is equal to 5 ampere. Because this is the current. Even though the equation tells us it's a 3 VB, but actually it's the current. That means when you calculate this thing, the value here, you need to take this value VB equal to 2 watt. But you cannot take the watt inside here. You just take 3 times 2, you get 5 ampere here. And for this circuit, it's called the voltage control current source here. So back to this example here, you can see the VB. Okay, you can see the VB, but this one is the voltage. How do I know the voltage? Here, same again, VB. But this now the symbol is a bit different. Now the symbol is not arrow, is with some polarity here. Okay, and this symbol tells us is the voltage source. Let's say this is the VA, this is the 5 VA. So right here actually is this one depend on this one. You can say that 5 VA depends on VA. I think this is very clear, right? Because if the VA change, this one will change. The 5 VA will change. So example, if VA is equal to 2 volt, that means 5 VA is equal to 5 times 2 equal to 10 volt. So the whole thing here is called a voltage control voltage source. Voltage control here, controlled by this VA, and this is the voltage source. Because this is some kind of voltage supply. Sometimes looks like you can figure this one as the battery, something like battery. Voltage control voltage source, and the example, the previous example is a voltage control current source. So we have total we have four. We have 4 possibility here. You can find in the circuit. Some component in the circuit, they actually function like the voltage control voltage source, current control voltage source, something like you can find in the amplifier, something you can find in the transistor, because transistors sometimes they are amplifying the some kind of power, right? That they can amplify current and amplify the voltage. That's why we use it in the Wi-Fi, right? We can boost the output sound, right? We can design something to boost the power. That means some kind of power is controlled by the current. Sometimes the power is controlled by the voltage. That's why we call it the voltage control voltage source. Okay, you will see all this when you're moving along. You will see all this circuit. Sometimes when they try to do the modeling, they call the modeling, circuit modeling. In engineering we call it circuit modeling. When you try to model something, sometimes they use all these voltage control, current source, and there are 4 possibilities here actually. They actually apply to the real component in the practical world. That means the amplifier, the transistor, the transformer, everything that can control something, whether it's a voltage control current or current control voltage. Many components they have a different behavior. Some is a voltage control current, some is a current control current. Okay, all this we can use for circuit modeling actually. So that's why here you need to get to learn about all this. We call the dependent, or some is the depend or independent source. Okay, this is independent. Independent means it's just stand alone here. Independent, stand alone. But here something is dependent. Dependent means here depend on this. This depend on this, right? This depend on this. This depend on this. This is what we call the dependent. It may sound a bit confusing, but you just need to get it clear why they say dependent or independent. You need to make it very clear before you can move ahead. All right. So there are 4 possibilities. I don't want to go through every one of them. There are 4 possibilities here: current control current source, voltage controls current source. Or there are 4 possibilities here actually. Okay, let's come to the next one. The next actually also something from the physics also. This equation actually is defined when there's a conductor. We have a conductor. When we amplify this conductor, we have the diameter, and then we have the area. From the diameter, we can calculate the area, the cross-sectional area, and then if we given with the certain length in the conductor, because each different material, they have a different we call the resistivity. Okay, by given the different resistivity, looks like P here. If you know the length, if you know the area, then you can calculate the resistance for this material. So the material we are talking about are mostly conductors like the copper, like the gold conductor, like the aluminum. Okay, all these conductor, they have, each one of them have a different. Of course, they have come with different conductivity or the resistivity here. Okay, defined by the resistivity, length, and the area. Okay, so whenever you are encounter with some kind of material, you need to calculate the total resistance. Let's say for 100 meter, what is the total resistance for this material in 100 meter? If you know about this so-called the resistivity variable, you know about this value, you know about the length, and you measure the area, that means you can calculate the total resistance for these wires. Okay, it's easy to calculate the resistance in this wire. You don't need to measure it actually. Example, in a power transmission line, let's say you have this cable stretched across 2 kilometer, and then if you know the value here given by the supplier, the resistivity, okay, the resistivity here constant. If you know this based on certain material, sometimes the material is a copper. Example, copper, very common. They use a copper. The copper, they have a fixed resistivity. You know the this one, and then you know your diameter. You can calculate the total ohm from here, from this point to this point. What is the total ohm in the line? Okay, you can using this equation. So sometimes it's quite helpful lah. Okay, you don't need to take the multimeter or take some meter, try to measure the wire which has 2 kilometer in length. You don't need to do that physically. Actually, you can use the equation to calculate. Okay, or to predict the total resistance. So somehow you need to memorize this formula here. Okay, but if you know there is some formula which define the total resistance based on the p value. Okay, that means you in the future you can use Google to search for this equation, but you must know there's some equation that you can use to calculate the total resistance. Okay, when it comes to resistor, I think this one you should know, right? There's a color band here which tell you the total resistance for this resistor here. We look at the band 1, band 2, band 3, right? Look based on their color, and then we can calculate the total resistance. And for this one, you can go to the YouTube. I think many people will teach you how to read this color code. Okay, but for now we have to skip here. Okay, now we come to the very important topics here. So before we begin, we just need to get to know these three terms here. One is called the branch, one is called the nodes, one is called the loop. Okay, this is quite, especially for the beginner, this is quite important right now. Let me save this one first. Okay, so by given this circuit here, what is called the branch? Branch. Where is it? Where is called the branch? Okay. So the branch here we have one. This is called the branch. Right? 2, 3, 4, 5, 6, 7. So we have 7 branches. Okay, 7 branches here. So how about the nodes? How many of them? This time I already show you, right? You cannot say here's a node, here's the node, right? The node must be a, because there's a node when there's a voltage different. Let's say you say here's a node. I think it's quite valid because between here and here, this looks like a junction. This junction can lead to this component or this component here, or this element here, or this element here. So you can define this one as a node. And also after this resistor, after this component, the voltage will be dropping. That's why it's safe to say that this is another node. Here is another node. But this node is the same actually. There is no potential difference between this node. There's no voltage difference between this node. So 1, 2, 3. Here's 4. 1, 2, 3, 4, and this is 5. Total of 5, right? 5. Okay, because you need to identify which one, how many nodes are there before you can begin actually. Before you can begin analyze the circuit, you need to know how many nodes are there in total. All right, so 5 nodes. The last one is called how many loops? Because loops associated with the current usually flow in one loop like this, loops. Within this loop, we have the same current actually. Let's say the I1. Within this loop, all the current is the same. I mean, the I1 is flowing through this, I1 flowing through this, and I1 flowing through this wire. Okay. How many we have loop? We have 6. 1, 2, 3, and then this big one, 4, 5, and then the 6. We have 6 loop. So it's quite messy actually. When it comes to loops, it's quite messy. Okay, if you can try your own. How many loops are there? Start from here. 1, 3 inner loop first. This is called the inner loops. So this is slightly bigger from here to here, slightly bigger, right? So you find all the possibility, you can come up with total of 6 loops. Okay, but when it comes to the loops, usually we only use 3 loops only to make our work easier. Sometimes we only use the 3 loops. We wouldn't use up to 6 loops actually. But for the nodes, definitely we'll use 5. We'll use all the 5 nodes. Okay. For the branch, for the branches, sometimes we not actually calculate how many branches. So you can say that when it comes to circuit analysis, sometimes we use for this example, we use only 3 loops, and then we use 5 nodes for circuit analysis only. Okay, but if you want to calculate total, this is the answer for the total, right? But when it comes to circuit analysis, we only use 3 here and 5 nodes. We use all the nodes, but you only use 3 loops. We don't use a branch usually. Okay, we don't actually use a branch. Okay. Sometimes try to be a bit flexible. Just understand that. Just understand what we mean by branch or branches. Okay, try just to understand the meaning of this word, the loops. All right. So we are halfway through. We are 24 out of 55, but we need to cover a bit of Unit 2 also. Okay, right now we come to a new topic here. Okay, let me see here. We are still got a long way to go. A long way to go. But we need to take a break right now. How about we take about 5 minutes break right now? Okay, we still need to take a break right now.
Yes, okay, 5 minutes.
Yeah, we have our meeting until the 10:30. Oh yeah, we have some students joining here. We have meeting until the 10:30 here. But I need to take some water. Okay, let's take a break for 5 minutes. For all the students here, please type your name at this box here so that I can do the attendance later on. All right, please type your full name here. Example, the Silveraman. Okay.
Yes,
so
Silveraman.
Yeah. Okay. I think we still have 2 students waiting for their full name here. Okay, hold on. Let me get some water. All right, let's continue from here. Okay, I think there are many students still having trouble to sign up to Microsoft Teams right now. Let me check whether anyone they post any message or not on the online forum. WOU actually they emphasize they try to promote the online forum. They hope that most students can make use of this online forum to exchange their information. So in the past, we tend to using the WhatsApp a lot, but when it comes to the audit, audit by the MQA, the government officers, they like to see some proof that there's a interaction between the tutor and the students. So actually, what they can come to this online forum to see all the progress, all the evidence of the student and tutor exchange their information, and that means they are learning this interactively, not by a pure individual. There's something to help them to understand all the let's say the way about and all the way about of the information, and when they face any difficulties where they come to get the help from other student or tutor. That means that you try to utilizing this discussion forum here. Whenever I have anything, I will also share it on this folder. But I can see that not many students they are posting here right now. Okay, never mind. Let's proceed here. To set up a WhatsApp app, sometimes it's really annoying. Because sometimes whenever I post one message in the past, when I post a message, sometimes we got student reply, okay. Then in a group of about 40 students or 20 students, you'll get many replies. And then sometimes the message coming in the midnight, sometimes will wake you up also. That's why the WhatsApps, even though it's really helpful, but sometimes I think it's the price we need to pay when using the WhatsApp. That's why I'm a bit reluctant try to use WhatsApp right now, because I'm handling a few more classes here. So we have students of over 100 students. Sometimes the message just coming in, all the time. Every minute, probably I receive one message. Sometimes you actually use up a lot of time actually. But we'll see how it goes, okay? But at least you got something here. You can post your question. Actually, we'll try to get back to you within 24 hours, okay? And the best part is when you post question here, you'll be captured by the Wawasan Open U. It's proof that there's an interaction between the tutor and the student. So if I answer you through the WhatsApp, even though I answer you at 1,000 messages, WOU wouldn't know anything actually. When they come to this discussion forum, they say when they see the zero interaction here, there's no message posting on the discussion. They thought that the tutor didn't answer the student at all. Sometimes this is there's something doesn't work, doesn't sound so right actually. Okay, that's why for this semester I try to switch to this discussion forum here for the reason I just explained earlier on, because I can actually answer your question through the WhatsApp, but the WOU won't see anything actually. They won't see that the efforts that we put in into the WhatsApp, but they judge our work based on all these their portal, their online portal here. So it's something that look really strange actually. Okay. So you, as long as you post question here, I'm sure if I'm not in time to answer you, I think our CC will answer on behalf of me. Okay. So I still recommend to use the discussion forum actually for the goods of all the parties. Okay. Let's get back here. This topic talk about the serial and parallel elements. Okay, this word I don't know whether it's familiar to you or not, serial and parallel, but I can make it, I can draw something that help to quickly explain this too. When it comes to serial, it's something like this. We have one element here and another element here. They kind of like connecting in one string. From here is one wire, and then this output. There's the wire exit another side here, and this wire also connecting to the next element, and then this wire coming out from the second element here. So this is called the serial. Something like state lah, okay, like state, looks like state. So we have the opposite of serial is called parallel. That means these two elements, they are side by side, up and down, something like this. So you have this wire going through this element, and this wire also the same knot going through the second element also. The same wire here. So basically we have only two wires. You can, if you think this one is the wire number 1, wire number 2, this is just another copy of the wire because it's connecting to the same node. But this one you have 1, 2, 3. You have node 1, you have node 2 and node 3. All these voltage are different. The voltage after this element will drop. Voltage after this element will drop some more. So we have 3 voltage here, 3 voltages here. For this parallel things here, for this parallel connection with only 2 nodes, you can see, because these 2 elements, they are sharing the same nodes. That's why we call it parallel. And these 2 elements, they are not sharing the same nodes, but they're sharing the you cannot say they are sharing the same current actually. Current. When there's a current here, the current sure will be the same through these 2 elements. But with the current, there's a current here. Current more likely to split into 2. 1 and 2. I1 was split into 2 more, different value, all different value. For this one, you can show that the I only one current going through these 2 elements. This is called a serial. All the current is the same. but we have multiple voltages, multiple nodes. When it comes to parallel, we have 2 nodes only, but we have multiple branches. You count the branches here, multiple current. So these are the different here. Why they need to have this serial and parallel connection, because they just behave differently actually. Okay, so for the student they just need to identify which one is a serial, which one is a parallel. You look at this example here, these 3 elements, they are sharing the same nodes. Basically, we have only 2 nodes only, one at the top and one at the bottom. Basically, we have only 2 nodes. So basically, we're sharing the same nodes here, like my example here, sharing the same nodes. That means this is the parallel. Okay, parallel. And where's the serial? This is a serial. So serial has multiple. I think my one is better. Serial is a multiple nodes voltage here. Okay, let's continue. So you look at this another example circuit here. Some are in parallel, some are in serial. Okay, these 2 are not in parallel, even though they look parallel, but they are not in parallel because they're separated by 2 different elements here. And then the voltage, the node voltage here and the node voltage here is different. The node voltage here and the node voltage here also different. So we have 4 different node voltages. So these 4 elements, they are not serial, they are not parallel. These 2 are parallel. As you can see, right on another slide here. You can see in the center here, it's not easy because it's quite complex here. The way how they arrange it is quite complex. But we can look at the outside one, the outside these 2. You see this node, actually is same with this node. This node, same with this node. That means these 2 are sharing the, let's say the V1 and V2. They're sharing the same node. So these 2 are parallel. These 2 are in parallel formation. Okay, these are messy because all the voltage is different. So we won't look at this one as a parallel or serial. But we can look at here. Let's say here is a 1 voltage here. Let's say this is V3. And then after the resistor, we have another node voltage called the V4. After the resistor, we have another voltage called the V5. So you can see these 2 elements, they have 3 node voltage. That means they are in serial. These 3 are in, these two are in serial because 2 elements, 3 voltages. So they are, both of them are in serial. Okay, 1 and 2, 6 and 7, 3 and 4. 3 and 4 are not right. So 3 and 4, resistor series, as both resistors are connected to the same node. No, this is wrong already. And carry the same current because they are separated by this ohm here. The current is the same. The current is the same inside this loop. Okay, based on the current is the same. That's why they say it's a series. It's a series. But I think this is a bit misleading. Yeah? Let's say the 6 and the 10, the 6 and the 10 ohm, they are not in the series. The 2 and the 10, 2 and the 10, they are not in series or parallel. 5 and 10. These two are parallel, of course. These two are parallel. Probably that these 3 and 4 they're considered as a series because they're sharing the same current. Like my previous example, they are sharing the same current. This one also shares the same current, right? This one is questionable. This statement number 3. I think this is debatable. This number 3, but as a student, usually you just need to identify the most obvious one, like the outside one. Actually, most of the time we work from the outside in. From outside, we slowly work inside. Okay, these two after reduce, we come up with another component here. The total here, the total of these two, and then we continue with others. Okay, then we just work all the way in. Okay, from outside in to inside. Then we can reduce the circuit into a much simpler form. Okay, so at this moment, you just need to identify these two are parallel, these two are series. Is already good enough, okay, for this stage. You don't need to worry about the thing in the center. Because in the center, there are too many joint, too many nodes here right now. Usually, we won't bother to look at the center one. We will start from the outside in. All right, now we come to a very important law. The first law I think you learn in this class is called the Ohm's law. Okay, Ohm's law. One thing I can help you is you can try to visualize this one in your brain. V I R. Okay, then you draw the divider like this. Okay, so V equal to IR. V equal to IR. I equal to V over R. I equal to V over R. R equal to V over I. So there are 3 possibilities here defined by the Ohm's law. The Ohm's law defines the relationship between voltage, current, and resistance. Okay, example, you have one element here. This element has the current flowing through. Okay, and this element that has a resistance is a non-resistant here. We know the resistance value, we know the current. That's why we can calculate the voltage is equal to I times the R. So this is the beauty of this law. Based on this law, you can calculate the value, the unknown value. For another example, okay, another example. Okay, let's say you know the current here. Let's say you know the current is 1 ampere. And when you're using the meter, you try to measure the voltage across this element. Let's say you come up with 2 volt. Okay, then that means you can predict the resistance of this unknown element. The resistance of this unknown element is equal to the voltage divided by the current. So you get 2 ohm. So when it comes to practical, sometimes we can find out the resistance value if we know the other 2. We know the other 2, we can find out the unknown one using this law. So this law is kind of the must. I think the must in circuit analysis. You need to memorize this one for, I think, forever. Need to memorize this law. You shouldn't forget this law actually. This is the most important in this class, I think. The most important equation in this class, the first law here, we call the Ohm's law, coming from one scientist called the Ohms. I think the last name is called the Ohms, something like that. Okay, by using the Ohm's law, of course, we can predict the other value here. Okay, and this one is not actually the Ohm's law. This one is come from physics also. Okay, because so far I think you know what is called resistance. You know what is called the resistance by the symbol R. There's one resist the current flow. Okay, actually you can visualize this one as the water in a pipe. Actually, let's say you have one tanki here. Okay, the water reservoir to store all the water here. So you elevate this the tanki above certain height. This is the ground level. So because this water is above the ground, that's why we have a potential. This is the potential. In physics we call the potential energy. This potential we call the voltage. Because of this voltage, this is why the current can flow. The current is in the water can flow down. This is the pipe. Okay, so the current define how much water can flow down in a given time. Let's say 1 second, how much water can flow down is the current. So the current actually is the flow rate, the water flow rate. The height of this the water above the ground level is a voltage. It's called the potential. So the resistance actually is the all the dirts, all the build up, all the dirts, which stop the water from flowing through, which block the water. This is called the resistance. Just like our blood vessel also, blocking our blood flowing through. Okay, that's why we have this we call the cholesterol, right? Cholesterol. It's blocking all the flow of the water because of this dirt build up here. This is called the resistance. And the reverse of resistance, if you take the reverse of resistance, actually it's called the conductance. Conductance, the symbol is G. This is called the conductance. That means this defines how good the current can flow through, how good the current is flowing through. This defines how difficult the current can be blocked. Okay, how and what level it can block the current. This one defines how the reverse actually how good the current can flow. Okay, so they are totally reverse. So when in the upcoming topics, sometimes you can see the G. So what you need to do actually, you just take the 1 over R to calculate the G value. It's just they call the reciprocal. Reciprocal, in other words, the reverse, the reverse. Like the earning money is one thing, right? And spend money is another reverse thing, right? Earn and spend. So you can say spend is the resistance, earn is the conductance. They are totally reverse in nature. Okay, but when it comes to this engineering, they like to sometimes they like to change to G for the reason that easier to calculate certain value. To make it easier to calculate the next value, they prefer to change the R to G sometime. Okay, so now you just treat them as an opposite will do. All right, so we have this example how to calculate resistance in this element. So we already going through this one using the formula here. We talked about in the morning. Okay, using this formula by knowing the resistivity, the P value, actually we can calculate any resistance of any material actually. All right, then we come to this another important topics here. Besides the Ohm's law, This is the second law that you should be familiar. Okay, be familiar with this law. Actually, this law divided into two. We have a current law, we have the voltage law. Okay, let's get right into this current law first. So the current law said that the sum of all the current into one node here, the center, is equal to 0. The n is the number of current 1, 2, 3, 4, 5. The sum of all the current into one node is called, it must be 0. So it's very simple, right? But when it comes to the formal definition, it said that the algebraic sum of currents entering a node is 0. That means this equation here, sum of all the current, algebraically, sum of all the current must equal to 0. This is the current law. Okay, sometimes it appear in this form. You see the current, sometimes I1 is a positive, I2 is a negative. But if you sum all of them together, they must be equal to 0. So we can use this law to analyze many circuits based on this law. All right. So another one is called the voltage law. The voltage law is about very similar to current law, but it's is sum of all the voltages in one loop. So they are bit only slightly different only. One is talking about the node. One is talking about the node voltage. So if I want to simplify this one, KVL dealing with sum of all the voltages in a loop. So this is a keyword. Sum of all the voltages in a loop must be equal to 0. Whereas KCL, sum of all the current, sum of all the current here. This is sum of all the voltages. Sum of all the currents in the KCL in a node. This is a keyword. Must be equal to 0. Sum equal to 0. This is the proper way to express the statement here. This is a proper way lah. Okay, by using the different kind of methods. Okay. Right. Let me show the example here. You know that sometimes to talk about all this using the words, using the equation, sometimes you still not so clear about it, all this. Let me show the example with the real circuit. Okay, let me show with the real circuit here. So the reason why I try to show you this is actually this is very important. I hope you are hearing this right now. Our next session, which on next week 24. Okay, and it's a 5 hours session. We're going to do some labs, do some simulation, online simulation. In the past, the students need to come to the lab and do the building up a circuit on the breadboard. But due to MCO, the student just need to complete the online simulation. So I want you to before you come in to the class next week, I want you to register yourself with this multisim.com. It's a free service actually for the limited feature. So you come to this website, you register yourself, create one account. Okay, you will take probably a 2 minutes time. Okay, then you can actually draw some circuit here to simulate the to do some real good simulation here. Let me show you what is called a KCL here. Okay. Let me show you what is the meaning of KCL by using this simulation. So this is really we call it the modern tools. Actually, these are tools to help us analyze a certain electric circuit here. But it can be very helpful to students like you. You can use this one to get to know more about certain circuit. Okay, you can see now in this circuit in front of you, you can see that we have 4 elements. We have 5 elements. 1, 2, 3, 4, 5. With a total of 5 elements. One supplying the power. The other 4 actually absorbing the power. And then currently I put in this voltage. They call the voltage probe here. They call the voltage probe here to measure the voltage at these 4 nodes. 1, 2, 3, 4. At these 4 nodes, because this node is a 0. There's nothing here, just one wire. This one student, there's only one node here. It's right here. But between these 2 elements, we have 1 node. Okay. So let me show you by running this simulation. You can see the result right now. The simulation result. The supplying power of this battery is 10 volts. Okay, 10 volts. And after right before the first element, the 10 volts still there. After the first element, it dropped to 7.5. Okay. After the third element, after the second element dropped to 5. After the third element dropped to 2.5. And here must be 0 lah. After the 4 element must be 0. So if you take all the voltage across here, 10 minus 7.5, here is 2.5, 2.5, 2.5, 2.5. So what I mean is something like this. What I mean is something like this. When it comes to the KCL, we find the voltage drop. In technical terms, it's called the voltage drop. Let's say you have this voltage here. Let's say you have this voltage here. Let's say here is 10 volt. Here is 7.5 volt. So the voltage drop here is 2.5. 2.5 voltage drop. In technical term, we call it voltage drop. So you can see here, 2.5 drop, 2.5 drop, 7.5 minus 5, 2.5, 2.5, 2.5. The sum of all the 2.5 must be equal to 10. Because this is supplying power, this 4 absorbing the power. So in KCL, can be written like this. The sum of all the voltages start from minus 10. Because here is a minus sign. Minus, then positive, positive, right? Minus 10 plus 2.5 plus 4, 2.5. Okay. Sum of all the voltages must be equal to 0. And the one with the biggest number here, the biggest value must be the supplying the power. The one with all the positive value here must be absorbing the power, consuming the power. This one supply, all this absorbing, but the sum of all together must be equal to 0. This is defined by this KVL. Okay, you can try to do your own kind of a simulation later on. Let me show you the KVL. Okay, let me show you KVL right now, real quick. KVL, let me show you the KCL. Oh, kind of slower. Oh yeah, I need to stop. I need to stop it before I can switch to the other. Oh, sorry, the wrong one. Sorry, so wrong one. My circuit. Okay, let me show the KCL right now. What do you mean? Sum of all the currents equal to 0. By analyzing this circuit here, or simulating this circuit, actually we can prove that the KCL is true. Okay, what the law say is true actually. When you're doing the real circuit building, you simulate this one on the real circuit, you also can find it's a true also, not just simulation. All right, you look at this circuit here. We got one supplying power. We call the voltage source here. I got 3 more resistor, which is here to absorb the power, to use the power. Okay, right now I have the current. Showing at each branch. I have a green color one here, a light blue and a dark blue, and one purple and one gray. I have 1, 2, 3, 4, 5 with 5 currents here. Okay, but we look at the nodes here. Actually, we look at the node right now because the KCL. Look at the node only, one node at a time. So we look at this node here. Okay, let me run the simulation. Let me run the simulation and show you the result. Okay, you can see here. This current is going into this circuit here. So let me try to analyze using the using my whiteboard here to prove to you. You can see on this real simulation, 2.5 milliampere is going this way. 2.5 milliampere, and another what current is going out from this node here is 1.25. Another current is going out. So 1 in, 2 out. If you want me to redraw again, 1 in into the node, 2 coming out. You can say one supply, one to absorb, using. Okay, one supply, 2 using. So this one is 2.5. This why when you sum all the current in the node here, in this node, my 2.5. Okay, let's say this is a 2.5 here. It's going this way, positive 2.5. Okay, but the one leaving the nodes here should be negative. Or you can write something like this. Sum of 2.5, this is the entering the node, equal to the one leaving the node. Leaving the node is 1.25 plus 1.25. So these two are leaving the node. So you put all together, sum of 2.5 minus 1.25 minus 1.25 must be equal to 0. So this defines which one enter, which one leaving. Okay, and you look at, by the way, if you look at this current here at the bottom here, and also this one, if you pay attention, there's a negative value. You don't need to actually worry too much about this negative value here, because the current on this circuit is showing this direction, but the value is negative. That means the current is actually in this direction. Current is actually in this direction, 1.25 in this direction. When you show different direction, that's why you get the negative value. So this one also apply. The current should be in this direction. To get the positive value should be in this direction, not this direction here. So you can say the current is flowing like this in this loop. Also in this loop like this. See the current coming down and then go to the left. So we have loop 1 and loop 2. Exactly flowing the same direction here. This one's showing the reverse direction, that's why you get the negative value. Okay, but today we are not concerning about the loop here. We just focus on the node. 2.5 entering, 1.25 leaving, 1.25 leaving. Sum or all together must be equal to 0. Okay, try to analyze yourself later on. Okay, you can follow exactly the same drawing here, actually the same setup. Okay, try to understand current going in, current going out. What is the meaning of all these positive and negative value here? Okay, and then I think after you've done enough simulation, I think you should understand what is the real meaning of the KCL and KVL, and this equation also. Sum of all the voltages equal to 0 in a loop. Okay, without this keyword in a loop is incorrect actually. You must insert this you must use this word. You look at your example, you look at your assignment. Briefly, 1B, question 1B, answering the following question, briefly explain Ohm's law. Okay, but it didn't ask you to explain the KCL, KVL, right? But in the lab, in the assignment number 2, you need to explain the KCL and KVL. That's why when you explain it, make sure you don't leave out these keywords here in the loop for KCL. For KVL is, for KCL is in the node, entering a node. Here's got one example here. We have one example. You can see that we have 2 loops here. Okay, and each element carries one voltage drop V1. This one V2. Okay, but first we're applying the KCL at this node A. I1 is entering the node A, I3 leaving, I2 leaving, just like my simulation just now. And you can write this formula or equation. The first equation you can write based on the KCL law is I1 minus I2 minus I3 equal to 0. And in your assignment or in your exam, you need to be able to write down this equation by yourself by looking at this circuit. By analyzing this circuit, you must able to come out with these equations. This is a requirement. Okay, so you must learn how to write this equation here. So the second equation we can write actually based on the KVL. Using the KVL, we can write down this equation. Let's see how we write down this. Okay, so here, let me pull this out and explain you on the slide here. So when you analyze this, analyzing this circuit here, you should start from certain point. So we like to start from the point here. So imagine yourself, you following this path, you go right through the first element, the power supply. The first thing you see is negative. right? You're coming from this way, you're going the way up, you first thing you see is the negative, not positive. Positive is exit. So you can say negative 30 volt, and then after that, you're arriving here. You're going to go through this element here. The first thing you see is the positive. So positive V1, and then you make a turn here because you sum in a loop. Remember the KCL, sorry, the KVL is about the loop. So you're going through a loop here. The first thing you see here is the positive, so the positive V2. And sum of, there's no more, right? Here's no more. So the sum of all the voltages must equal to 0. So these are the, this is the second equation you can write down. And later you convert this one to another form using the Ohm's law. Okay, because V1, based on this this formation here, V equal to I times R, equal to the current multiplied by the resistor. So V equal to the current I1 multiplied by the resistor 8 AI. Looks better. 8 AI. 8 I1. 8 I1. Okay. I1 8 is a bit look a bit strange. 8 I1 looks a bit better. So this comes from here. V equal to IR, Ohm's law. So you can do the same for the remaining loops. Eventually, you can solve all the current and all the voltages across each element here. So nowadays the students are really lucky. What I mean is, you can come to online free service here. You can draw the circuit, and you can ask the program to show you all the current, all the voltages after the simulation, and then you need to compare with the one you done it manually with your hands. Okay, to compare whether you can calculate the all the values here by yourself. Because in your exam, I don't think you have time to do the simulation online, to draw the circuit and to get the result. It takes certain time. Okay, but we are in this class, we want the student to learn how to analyze the circuit by themselves, not using any software. Okay, so you need to do it by yourself here. All right, so you can go through it, and here, slide number 42 here, we come back to this series and parallel again. The series circuit and the parallel circuit. Okay, so you look at the first example here, all the resistance in the circuit, you can just sum them up like this. The R1 and R2, I think this is quite simple actually. You don't need to worry too much. Let me show you. The total resistance here, there are two resistance here and one power supply. Most of the time, what we want to do actually, we want to simplify these two into one. We combine two into one to make so that we can analyze the circuit further. This one usually is called the RT, R total. So the R total for these two is quite easy. You just sum them up in series. Because they are in series, we just sum them up like this. When you are dealing with the resistance in a parallel form like this parallel, because they are sharing the same nodes here. Parallel is a bit tricky. The R total for these two is in the symbol. This is how we write it, parallel. Okay, but usually I will use the formula straight away. Usually this formula is the one I will use. I just multiply R1 by R2, and then I divided by R1 plus R2. This is the formula I like to use frequently. But the real formula is defined as R total is equal to 1 over R1 plus 1 over R2. Okay, but whether you're using this formula or you're using this formula, you end up with the same result. Actually, you can do a test later on, but right now, because of the time concern, I cannot show you both are actually equal. Okay, but I like to use this formula. It's easy to memorize, really easy to remember. This one sometimes it's easy to remember, but not easy to work with actually. Let's look at a further one. And forget about the G. Okay, the G is the reverse. Everything is reverse. I don't think you need to know it right now, otherwise you'll get confused. You can forget about G at the moment. Okay, just focus on R only, because R and G, they are just reverse. Reciprocal, they call it reciprocal. Okay. Here's the no, this is not what I'm talking about. Okay, here got one example here for you to practice your skill. So you can see we have 1, 2, 3, 4, 5, 6. We have 6 elements here. We need to find the R total. Another words for R total is R equivalent. Okay, you know that we cannot just sum this one and this one because they are different formation. But we know that these two look parallel because they're sharing the same node here. Okay, let me show you. This node and this node is the same. This node and this node is the same actually. This is not just one wire. So these two are parallel. These two also 4 parallel 12. After you get these two done, you reduce the circuit to like this only. Then everything looks easy. Everything is serial because one current can flow through everything here, right? So these 4, you just sum them up. Sum up these 4, you get the R total. First, you must solve the thing inside here. You must solve this part before you can come up with before you arrive at this much simple formation. Okay. You can try it yourself. And here show you some detail how to solve this one, step by step. But what I suggest to you is that you try to do it your own, and later on you come back to compare your answer, whether you can get the right answer or not. 9 ohms the answer. Okay. So the last topic here is talking about this conversion. Sometimes we can see the resistor in this format, in this form, right? Looks like Y sharing a same node here. So if you visualize it in the different form, it may look like this also. These two are the same. So this is called the Y formation. The Y form, right? But somehow they just name this one a Y. The BUYE, they call it Y. Okay. We seldom use T usually. We use the Y. We use the Y. Okay. The other formation is the delta. Looks a triangle delta. So delta, you cannot say it's a series. It's not a series actually. It's not a series. It's sometimes something like a look like a series, but they are not series actually. Okay, and you may also visualize this one like this because this is the same node here. This is the same node, so you can expand this one as a one wire. You can convert this node as a one wire here. So they both of them look the same actually. They behave the same, but they look differently. They behave the same. Actually, we can convert this one. We can convert this one to this. Let me start with the new slide here. We can convert something in Y to delta. We also can convert from delta to Y. And right now, probably you think that this is not really useful, right? I can tell you when you come to circuit analysis, sometimes you're seeing some kind of circuit which you have no way to continue unless you can convert the circuit. Example, let's say you have a circuit like this. Okay, circuit like this formation. Okay, and you want to find you are required to find the R total of this 1, 2, 3, 4, 5. You want to find the R total of REQ equivalent of this 5. You don't know where to begin. This one cannot series. This 3 cannot series. You cannot just do the series like this, right? Because you need to consider this one also. The only way you can do is to take away this one in the center one. If you can take away this 3, then the thing look differently. Your look different, enable you to continue to the next step. So this one actually is a Y formation. Here, here, and here. Here, here, and Y formation. We can convert this one into delta. When you convert to delta, you look like this eventually. So parallel, parallel, parallel. We can solve these 3 parallel, then we end up with all in series. But when you arrive at this stage, you have no way to continue unless you know how to convert this 3 into delta. Okay, so the method here show you how to convert. You look carefully here, the example. You see the solid line here is the original circuit. The solid line here is the delta. We try to convert this one to Y. The Y is the dotted line here. The dotted line inside the delta. Let me put this one outside here also. Okay, let me use the color. The red color line is the one is original circuit. Here, it's the original circuit. The green line here, the dotted line here, is the one you want to convert into. From the outside, convert to the inner here. That means you convert from here like this to this. So what are the formula? R1 actually equal to B and C. Okay, R1 R1 is here. Wait, R1 is here, sorry, R1 is here. Equal to RB times RC. What is RB times RC? This is A, right? I hope I can enlarge this one. Still very small. Let me try to get another new slide. Hold on. You see, we want to calculate the R1 here, our purpose here right now. To calculate R1, we need to take the B and C. So B and C actually they are adjacent. This is called the adjacent to R1, right? They are like neighbor to R1. So the B, take the one adjacent to R1, which is the RC and RB, then divided by RA plus RB plus RC. So it's quite simple, right? Divided by the all the external one. So the denominator here is the sum. The numerator here is the one adjacent to R1. So for the R2, the one adjacent is here, A and this is C, right? This is C. A and C. So for R2, the numerator is RA and RC. RA and RC for this R2. They are adjacent. And the bottom is the same. Let's double check. RA and RC, right? So by using this formula, if you can memorize it, you can convert from the delta to y. Okay. And then we can do the reverse also. Can do the reverse. Now the original is in y. The original circuit in y. We want to convert to delta, the outside one, the dotted line. Let's look at the formula. So the formula is a bit tricky. Let's try to study how to convert from delta to y. Okay. Let's see the we want the R this is RA, this RC. Let's look at RA first. RA in a dotted line means we want to convert into the one in the solid line is the original one. So RA is equal to what? Let's look at the formula again. R1, R2. RA equal to R1, R2. Right? R2, R3. R1, R2, R2, R3. R1, R3 divided by R1. RA here divided by R1. So R1 is here. To use this one, RA, the opposite to the RA is R1. We look at the opposite one, not the one near the RA, the one far away from RA. This branch here, R1. So R1 is our main denominator. We must decide R1 first. R1 is the one opposite the other side here, R1. So the top one is the same. R1, R2, right? R1, R2. R2, R3, and R1, R3, right? All the possible combination. R1, R2. R1, R2 is similar to R2, R1, right? So just one combination. R2, R3, one, another one. The important one is R1. And R1 is here, the one opposite. So for RB, one opposite RB is R2. And the top is the same. RC also, the one opposite RC is here, R3. RC, R3. The top, the numerator is the same. You just need to know how to come up this equation based on the given diagram here. Because in the future, if you come across the same problem again, where you need to convert from here into here, you know that there's a conversion methods you can use, and then you can quickly go to Google and search for this equation and do some quick review. You can actually convert this one into from the y into the delta. Okay, and then it can help you to solve the problem. If you refer to my previous example here, I showed that sometimes when analyzing a circuit, without these methods to convert from one form to another form, you cannot continue further. Your next step, you must convert before you can continue to the next step. You will come across this one soon, I think. In your final exam or your assignment, sometimes you need to do the conversion before you can continue to calculate the total. What is the total resistance of certain circuit? Okay. And I think today our time is up now. We plan to cover a bit in Unit 2. I think in Unit 2 we need to move a bit faster now. Okay, but this is what we can cover in today. So anything what is this? KD or KCL? KCL start counting by reverse. Okay, counting by reverse. I don't quite understand actually. Counting by reverse KCL. We are not actually counting. We sum all the current into nodes. We are not actually doing the KVL. You see the KVL. Let me save this one first. The KVL. Actually, KVL is something to do with the loop, right? The loop. It's not reverse. Actually, it's the starting from certain point. Starting from a certain point, actually, you see, let's say you have power supply here. Most of the time, power supply is a positive, negative like this, right? Let's say we have one resistor here, another resistor here, and then the KVL is something to do with the loop. This is a keyword. Loop means we need to have something like this, a loop. If you call this one reverse, it's quite confusing sometimes. If you start from this point, you go all the way up. The first thing you see is a negative. Let's say this is a 10, so it becomes negative 10 volt. And then the V1 usually the polarity positive. The positive polarity usually on the right, on the left hand side. So when you go into this, the first thing you see is the positive. So it's become positive V1. But we come to this is a KVL lah. For KCL, something we're dealing with the node. We're dealing with the node only, not the loop. So you need to memorize this one is the node. So when this one entering, this one leaving. So this is I1, I2, I3. So I1 equal to I2 plus I3. But putting everything together, I1 minus I2 minus I3 equal to 0. So I think I don't actually suggest you using the counting by reverse thing. It's a bit probably it works for you. Probably this way works. It works for you, but for me, it kind of confused my brain a bit. So no matter what, we choose the method that suits us best. Let's say this method you feel that it's easy for you to come up the answer, then you probably used to stick with the method that suit you best actually. But you still need to follow the general practice, our engineering general practice, how we define the KCL, the KVL, how we describe the circuit using the mathematically, how we express the circuit mathematically using this way. Okay, you still need to stick to the engineering practice. Okay. All right. I hope you're clear about this. Any question you want to you guys want to ask? We will continue this one next month actually in February. So I want to remind you once more about the next week 24, which is our lab session. So before you come to the labs, oh yeah, okay. Yeah, this I actually encourage you guys to using the discussion room. So next week before you come, I want you to do two things actually before you come to the next week's lab session. I want you to register yourself with this multi-sim free account. Another thing I want you to do is to download and install this software called the LT Spice. This one is another free software you can download and install it. And it also functions almost like the multi-sim. Because multi-sim is a limited feature unless you pair them. Otherwise, all when it comes to simulation, they have certain thing is not there. So I want you to download another software called the LT Spice. Freeware. Download it, small one, right? Very small, 43. Download and install it in your PC. And when you come in next week, we can straight away doing the simulation together. So what I want to achieve is we can all do it together side by side, okay? So that I can make sure that you can submit your assignment to effortlessly. That means you can easily complete assignment 2 without any using any brain power. You just need to follow step by step. We do it together, all of us doing it together, and then we putting our result into the Microsoft Word file. Later on, you can submit straight away. You don't need to redo again, okay? And then that will save you a lot of time actually. Okay, so are you clear about all this? We will continue later on the Unit 2 on the next February, the coming February. If you want to know the exact date, let me see. The exact date is February 7. Okay, but we need to go through this lab session actually on next week. So this is the thing I want you to take notes right now. All right, guys. Can we say goodbye now? Or you have any question for me? All right. Okay, thank you. Thank you all. I see you next week. Okay. Okay, bye.
Okay, bye-bye.
Bye-bye.
Okay, sir. Thank you. Bye.
Okay, bye.